Hi everyone, myself Dr. M. Lakshmi Prasad, working as an associate professor in the Department of Data Science in Institute of Aeronautical Engineering, Hyderabad. So in this video, I am going to discuss about the various questions that may come in presenting the data. So the very first question is that discuss in detail about various methods and rules for presenting the data. So what are the for presenting the data? So what are the various methods and what are the rules we have to be followed for presenting it? So the presentation of data, we have to follow this following principles. So the first one is that the data should be arranged in such a way that it will arouse interest in reader. That means that so whatever the data we are presenting or arranging, so that should be focused by the which is going to be focused by the audience should be very clear. It should be able to create some interest. Okay, it should be arouse create some interest in the reader, and the data should be sufficiently concise without losing important details. So what is the data we're presenting that should be made sufficiently concise without losing it important details, and the data whatever should be presented in the form, so that should be enable the reader to form the quick impressions and to draw some conclusion directly or indirectly. So what is the data we're presenting? So the data should be presented in such a way that so that should be easily the what the customer or what the audience able to absorb the quick impressions and able to draw a conclusion directly or indirectly, and should facilitate the further statistical analysis. So what is the data we are presenting that may lead to the statistical analysis, and it should be define the problem and suggest its solution also. So these are the principles first we have to be followed for presenting the data. So the very first thing is that the data what you are presenting that should be arranged in such a way that it should be able to create some interest in the reader, and the data whatever we are presenting that should be concise one without losing its important details, and the data whatever we are presenting that should be represented to make form quick impressions on drawn conclusions quickly, directly or indirectly, and it should also facilitate the further statistical analysis, and it should also define the problem and suggest the solution. And what are the various methods of presenting the data for this? So the first step is the statistical analysis to present the data in an easy way to be understood. And the two basic ways of presenting the data should be tabulation, and second one should be charts and diagrams. So right, so these are the mainly two things either we can able to represent the data in the form of tabulation form, and second one is that where you can able to represent the data in the form of charts and diagrams. So next, so what are the rules we have to be followed for tabulating presentation? So for that, first thing is that the table should be numbered, and what the brief and explanatory title must be given to the each table, and the headings and conclusions of the rows must be clear, concise, sufficient and fully defined, and the time or the data that must be presented according to the size of importance or to chronologically have to be arranged, or have to be arranged either alphabetically and geographically. So if the data includes the data proportion, mention the denominator. Then the table should be too large, the table should not be too large, and the figures need to be comparison should be placed as close as the possible, right? So the what are the rules that have to be followed for presenting the data is that, so first thing is that the table must be numbered. So since if I'm going to take any applications, there may be some around 20 to 30 tables. So which table is the first one and which table is the second one, we're unable to get it. So it is better to make the numbering of the table, and the brief and explanatory title must be given to each table. So what is the table I are taking? So some brief title should be given, and the headings and columns must be clear, concise, and fully undefined. So what is the headings and columns for you are taking for that? So that should be clear, sufficient, and concise and fully defined. And the data what I are presenting should be according to the size of importance, chronologically, alphabetically, and geographically. If the data includes the rate of proportion, so mentioned at the denominator, and the table should not be too large, and the figures needing comparison should be as close as possible. So for the continuation of that, so the classes what you have taken, so that should be fully defined, should not be lead to any ambiguity. So that is the thing you have to be considered. Since so many classes are available for any kind of application, so for that, so what are the classes we define that should not lead to ambiguity, and the classes should be exhaustive. That means that it should include all the given values, and the classes should be mutually exclusive and non-overlapping, and the classes should be of equal width and or equal or class interval should be the same, and open-ended classes should be avoided as far as possible, and the number of classes should be neither too large nor too small. A formula is that for the number of classes, how many will it be for any kind of application. For that, so k equal to 1 plus 3.322 log 10 base n. So where n is the total frequency, right? So the continuation of the guidelines for tabulation. So the classes what you are taking, that should not be lead to ambiguity is the thing, and the classes what you are having, that should be exhaustive. That means that it should include all the given value. There should not be the case of missing values, and the classes should be mutually exclusive and non-overlapping should be taken, and the classes should be of equal width and the equal class interval. Open-ended classes should be avoided as far as possible, and the number of classes should be neither too large and too small. There should be around 10 to 20 classes. How to find the number of classes for any kind of application will be here is, so k is equal to 1 plus 3.22 base n. This is the formula not to be considered. So here n is the full frequency. And the second thing is that, so demonstrate various charts and diagrams for presenting the data. So some of the charts and diagrams will be bar diagram and histogram, frequency polygon, cumulative frequency, scatter diagram, line diagram, and then pie diagram. So these are some of the diagrams that are available for presenting the data. So first thing is the bar diagram, and then histogram, frequency polygon, cumulative frequency curve. So these two can be obtained from the histogram itself. And scatter diagram is something different, line diagram and pie diagram. So let's see the first one, bar diagram. So this bar diagram is going to be used widely, and then it should be very easy to prepare the tool for comparing the categories of mutually exclusive data. That means the discrete data. So if I want to represent the discrete data, so this is the only tool that will available for representing that. That should be bar diagram, and different categories are going to be indicated on one axis, and the frequency of the data is going to be considered in another axis, where the length of the bar going to be indicate the magnitude of the frequency of the character that is going to be compared, and the spacing between the various bars should be equal to half of the width of the bar. So some of the different types of bar diagram will be simple bar, multiple or compound bar, and then component and proportional bar diagram, right? So this bar diagram is the very easy one, and this is the only tool that is available for representing discrete data, and the different categories are going to be indicated. So right, so that should be on x-axis or whatever it may be, and the frequency of the data is going to be considered under axis, that should be y-axis here. So the length of the bar what we are taking, that should be indicate the magnitude of the frequency of the character that is going to be compared. So the spacing between the various bars should be half of the equal to the width of the bar. So there are three different types of bar diagram, that should be simple, compound, and proportional bar diagram. This is the one way of representing this simple bar. So here I'm taking the types of what type of disease that should be on x-axis here, and y-axis I'm going to take the number of frequency, that should be the total number of cases of male that should be affected through VVAX, and falciparum and mixed malaria diseases. So this is the going to be indication how many number of people affected through this disease and how many number of people affected through this disease, so that I can able to make the comparison between these two and these two. So by seeing the bar diagram itself, it should be very clear. So many of the people are going to be affected this disease, Vivax disease. So since the value, that is the length of the, so it should be 100 and it should be 60 here and it should be around 30 like this. So by seeing this, I can able to predict that this uh, Vivax is going to be affected by many people. And multiple bar chart diagrams. So here each observation has more than one value, so represented by a group of bars, and the percentage of bars, that means that the percentage of males and females in different countries. So the percentage of deaths from heart disease in old and young, and mode of delivery in different female age groups. So for this kind of applications, that should be another tool that what we're having is a multiple bar chart diagram. So here, suppose the each observation should have more than one value, right? So that should be represented by two bars, and the percentage of males and females in different countries. Males and females are different countries. I want to find it out. So for that, the percentage of deaths from heart disease in old and young age and mode of delivery in different female age groups, I want to find out for this. So I have multiple bars. So same thing, I want to uh, find out how many number of males and females are going to be affected through these diseases. So for that, what you have to do, you have to take care of multiple bar chart diagram. So for that, so here the blue is going to be indicate the number of male people and red is going to indicate the number of female people. So previous thing is that within the single uh, criteria, single data I'm going to consider, but same thing if I want to go for the multiple thing, that means male and female, I want to find it out. At the time I have to make use of this multiple compound bar diagram. So similarly, how many number of males are going to be affected with this falciparum disease, and then how many number of males are going to be affected, that should be 62 and this should be 31, and mixed malaria is male is 29 and this one is 90. So thus I can able to predict this between uh, the two variables for a single variable. I can able to find out. Our next one is that compound bar chart diagram. So for that, the subdivision of the single bar going to indicate the composition of total divided into sections according to their relative proportion. So for example, if two communities are going to be compared in proportion of energy obtained from various foodstuffs, and each bar represents the energy intake by the one community, so that the height of the bar is 100 and it is divided horizontally in three components: protein, fat, carbohydrates, and each component is represented by different color of the shape. So this is the way of presenting of compound bar chart. Okay, suppose the subdivision of the bar indicates the composition are divided into sections according to relative proportion. So example, so two communities are going to be compared in proportion to energy that is obtained from various foodstuffs. So each bar represents the energy intake by one community, that should be height above 100, that should be horizontally. There are three components again here, that should be protein, fat and carbohydrate of diet. That should be represent different color of the shape. So take it out. So how many number of people uh, of the percentage of energy obtained by through fats, and that should be green color, and the percentage of energy obtained through protein, and the percentage of people obtain carbohydrate something. So I want to make how to make the comparison between the pure community how it will be and the rich community how it will be. So the percentage of obtaining fats in pure community will be more, whereas the percentage of fats in rich community is less. So here the percentage of energy obtained in protein is 10, but here it is 30, and here it is 10, and here is 15 for the carbohydrate. So like this. So component of proportional bar diagram means, so within the bar diagram that should be matches with 100%, and that 100% is going to be divided into different sections of different components. That should be component of proportional bar diagram. And next one is that histogram. It is very similar to the bar diagram, so with the difference that rectangles of bars are adherent without gaps, and it is useful for presenting the class frequency table for the continuous data. So up to the diagrams, what I said, that should be useful for the discrete data, whereas this one should be for continuous data. So each bar going to represent a class and its height represent the frequency, right? So the histogram is the one, so which is similar to the bar diagram, but here we should not maintain any gaps between the bars, and it is used for presenting the class frequency table for the continuous data, and each bar represent the class and height represent the frequency. Let's see this. So this is the class interval between 100 to 110 and 110 to 120, 120 to 130, like this. And within this, I have to draw this. So here on y-axis, I'm taking as number of individuals, and then distribution of studied of that group according to their height. I want to find it out. So in between 200 to 110 centimeters, how many number of individuals are there? So of 10. And similarly 110 to 120, how many number of individuals are there? Let it be 70. And between 110 to 120, 25. So in between this, how many number of people are there? The centimeters I want to find. That should be height in centimeters. I'm taking an x-axis. And next one is that frequency polygon. So here actually this frequency polygon is going to be derived from histogram for connecting the midpoints of the top of the rectangles in the histogram. So the line connecting the centers of histogram rectangles is called as the frequency polygon, and we can able to draw this polygon without rectangles, so that it should be simpler form of the line graph. So the special type of this frequency polygon is that normal distribution curve, right? So the frequency polygon is another kind of tool what we're having, and this one is going to be derived from histogram by connecting the midpoints of the tops of the rectangles in the histogram. That one I will show it in further slide. And the line connecting the centers of histogram rectangles is called frequency polygon. Here we can able to draw this polygon without rectangles, so that you can able to get the simpler form of the line diagram. The special type of this frequency polygon is the normal distribution curve. See this. So actually this is the histogram. So within this range, so this is the graph, we are having histogram graph, and within this range, and within this range, and within this range, this is the diagram, and within this one should be under rectangle, and within this range should be under 72. See here. So this is the actual histogram I'm constructed. So I'm taking the number of diabetes patient I want to find it out. So in between 120 to 120, right? 120 to 129. So how many number of people are there? Let it be 12. And 130 to 139, how it will be 8. And 140 to 149, 12. Sorry, 11. And 150 to 159, 10. And 160 to 169, 15. 170 to 179, 18. And this is also 8. So first I have to construct this. After that, so I have to find out the midpoints of the rectangles. And this is the points I got it. So this one is not here. This one should be this. So the midpoint of the this one is so I have to take the mid center of the rectangles here, and I have to join all these triangles. So after erasing this all the rectangles, right? So the data, the line what I created that should be the frequency polygon. Okay, so like this I have to construct the frequency polygon for that histogram. And next one is that cumulative frequency diagram or OQ. So here the frequency of the data in each category represent the sum of the data from the category and the preceding categories. Okay, so the cumulative frequency are plotted opposite the group limits of the variable, and these points are going to be joined by smooth and free curve to get the cumulative frequency diagram or OQ. Okay, these are the points we're having for the cumulative frequency diagram, or we can able to call it as OQ. So the frequency of the data in each category represent this sum of the data from the category and the preceding categories. Similarly, the cumulative frequencies are going to be plotted opposite the group of the group limits of the variable, and these points are going to be joined by the smooth and free curve to get the cumulative frequency of the diagram. So this is the diagram for the OQ. And next one is that scatter and dot diagram. So scatter and dot diagram can also call it as the correlation diagram. So it is useful to represent the relation between two numeric measurements, so where each observation being represented by point corresponding to its value on the each axis. In negative correlation, so the points will be scattered in downward direction, meaning that the relation between the two studies are in controversy. That is, that if one measure increases, then other decreases. Similarly, in positive direction, the points will be scattered upward direction. So, right. So this scatter diagram or dot diagram, or another name of this one should be correlation diagram. So here we are having maintaining two types of correlations. So first one is the negative correlation, and second one is the positive correlation. In negative correlation, all the points should be scattered downward, whereas in positive correlation, all the points should be scattered upward direction. That means that in positive negative correlation, so what is the points, what is the relation between the variables should be? So one variable increases, other variable decreases. In positive direction, it should be opposite to that. So see the points. So this is the cases. So in between where this is the points about it, right? So May 2030 and June 89, how many number of people affected malaria cases this one, and when it got 300 people got affected in July, 304 cases, and in August 450 cases. So like this scatter diagram I can able to construct it. And next one is the line diagram. So under a simple diagram where you can able to use the relation between the two numerical variables, but the points are joined together to form the line. So that is either broken line I can able to use, or I can able to use smooth curve. So it is going to be used to show the trend of events with the passage of time. Okay, the diagram what I'm showing, that should be a relationship between the two diagrams, and but these points are going to be joined together to form the line, that should be either a broken line or smooth curve, which is going to show the trends of even in the passage of the time. So I want to find that how many changes in the body temperature of patient after using antibiotic. So this is the first case 39. After that it should become 38, and then 38. Like this I can able to find, and then can able to join all the dots with the dotted line. That should be the line diagram. And next one is the pie diagram. So the pie diagram is nothing but it should be able to consist of circle whose area represent the total frequency, which is divided into segments, where the segments represent the proportional composition of the total frequency, right? So the pie diagram is the one which is going to be consists of the circle. That circle should be of equal to the frequency of 100%, which is going to be divided into different segments, and each segment represents the proportional composition of the total frequency. Now see, this is the example of this pie diagram. So here Vivax is 53%, and then mixed malaria should be 15%, and V falciparum that should be 32%. So what I have to do is, so initially I have to take this and then make use of this protractor. So I have to construct this 53%. It works not only like this, but make use of this. So 53% and mixed polygon that should be 32% and 15%. So this circle is going to be divided into different segments. So this is the way of constructing this pie diagram. And these are some of the references what I made for this slide. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.